to block diagram. So this lecture could be go close to 20 minutes or more. So let's see how long this lecture goes. But the other thing is that you can contribute for me. If you're liking this video, then you can go to Patreon. Currently I have no Patreon as I'm making this video, but still I hope, because I just made a Patreon account because somebody suggested me to do so. But anyway, that it's a good platform to contribute if you want me to continue making such videos, because the amount of revenue which right now I'm getting for my effort is very less. And also this full course will be available as a subscription on my website, the link of which is currently which is in process and will be available by end of June or even before that. So you can go, I'll update the website in my channel and on the description for this course. Also, if you still want to take the course before that, then you can drop me email on my business email ID given at the channel page. So I will respond to that and I will schedule you for this course and can discuss about the details. So it is like some 50 lectures in this full course will be about, and it's not going to cost much. So in this lecture what I will show is that I will just take the first example. So this is my input signal which is given by R, and this is my summing point, and this is my plus signal, and this is my minus signal. So this is whatever is my input signal, and this is the block diagram reduction. Example 1. And if I go ahead, there is one more summing point and both are positive here, and then this is my first transfer function which is given by G1. And again if you go, then I have this another function which is a feedback function coming from the output signal which is CS. And if you go, this is my positive, this is my minus, and this is whatever is G2. And then I will feed this back here, and it will, this is both are positive, so I'm feeding it back here. So this is my transfer function H1, and there is a simple feedback with no signal here, no amplification or no gain. So it is coming directly from the output. So there is two feedback. If you can identify, there is two feedback directly from the output. One is here and the other is here, and this is not feedback from the output, it is a feedback from G2. So this is a third feedback which is going. So there are multiple ways to reduce this. The ultimate way is to solve this such that you can find the input divided by, or you can find it in the form of your output divided by input, and my output signal is RS and my input signal is CS. So the first step one which I will be using is I will take this block here can be taken here. So to take that here, this I will have to divide this by, when you're moving towards your left, moving a block towards your left, you have to divide by g1 or whichever transfer function is here. So if I apply that step, then it will be something like, now I have 3 summing points here. This is connected to whatever is minus, this is plus, and this is h2 by g1, and this is as it is going ahead, and you have your g2 here now, and this is your CS as it is here, and you are feeding back your CS, you are getting your CS back to this, and this is h1 right now, and the other loop is coming as it is. So now this is a step 1 which you have applied. Now there is the step 2 which you can apply here. Is what you can do here. Now this step 2 is, you have to simplify this, so which will come as, or now again here there is also g1, so don't forget the g1 here. So this will now, if you are solving this whole thing, it will become, this both are in series, and you will have to solve this. So it will be g1 g2 divided by 1, both, this is positive here. Okay, so this is positive here, so the sign is always negative on the other side. So this will become negative g1 g2 and h1. So this is how you are reducing this block. Now after doing that, you'll have to replace this whole thing by that. So if I am simply using a eraser to erase this, so now this is my step, this was my step 2, this is my step 3 which I will be showing here, and I will be replacing this whole block here. So it is g1 g2 divided by 1 minus g1 g2 into h1. Now again there is a step 4. Now what is that step 4 is, now this is going into negative, and here it is a positive signal, and this is my RS and this is my CS. Now the same signal is being fed back to two different summing points. So that whole thing can be solved as, so we'll just erase the question here, just keep it in handy because I want to continue the calculation. So now the step 4 here is, you have to solve this full. So it can be solved as, G1 G2 divided by 1 minus G1 G2 H1 divided by 1 minus of G1 G2 divided by 1 minus G1 G2 H1 minus of H2 divided by G1. So this is how it will look like, and you will have to simplify that. If you look closely, then this will cancel out here, and this is minus sign here, and this is again why this is minus sign here, because the feedback signal here is minus, and it is already minus here by default. So this minus and this minus will make this plus here, so you can forget about this minus here, and this G1 and this G1 will cancel, and this will cancel after you move it here. So it will become G1 into G2 divided by 1 minus G1 G2 H1 plus G2 H2. So this is your final transfer function after solving this whole thing here. So now I can erase this and what I can write instead of that is G1 into G2 divided by 1 minus G1 G2 H1 plus G2 H2. Now there is a step 5 to produce a final result. Now the step 5 is, now if you consider that this whole thing is, simply consider that is equal to my G, then it becomes simple to calculate. So this is my step 5. Step 5, my output is R and input is R, and my this whatever signal here, it will be G into 1. This is minus, so 1 plus G. So why 1 plus? Because that minus sign will get into plus, and this is my CS and this is my RS. And if I solve this, then this is equal to G1 G2 divided by 1 minus G1 G2 H1 plus G2 H2 divided by 1 plus G1 G2 divided by 1 minus G1 G2 H1 plus G2 H2. So this is what is my final, and if this and this will get cancelled after it moves here, so the final answer will be something like this. So if I rub this whole thing, and for one and a final last time, if I write it here, so it will be something like G1 G2 divided by 1 minus G1 G2 H1 plus G2 H2 plus G1 G2. So this is my final transfer function which I am getting, and this is achieved on step 5, which is RS is equal to CS. So this is my answer, and this is how I can simplify my block diagram. So again, writing it in a very specific terms, my CS divided by RS is equal to G1 G2 divided by 1 minus G1 G2 H1 plus G2 H2 plus G1 G2. So if you look again, so this my initial diagram was something like this. Here was my input signal, then there was again a summing point, then there was G1, then there was again a summing point, then there was G2, and then there was CS. My output, this was my input. So this was plus here, this was minus here, this was plus here, this was again plus here, and this was minus here, and this was plus here, and I had a feedback coming here. So this was H1, which was coming from the output, and this was H2, which was again coming from the output, and I had another feedback which was coming from, or this was the final feedback which was again coming from the output to be here. So this is my output by input after simplification. Of block diagram. So this was my question, and this is my answer. So very clearly solved. You can cross validate that, and if there is any comments or any query regarding the answer, then you can email me or comment me. If you have this question has been solved very accurately, so if there is any specific query regarding the answer, then you'll have to email me for me to answer that. By just putting a comment, I will be not able to change this. So if you are coming with a validated proof that whatever I have done is wrong, then the answer is wrong here, then you will have to come through an email to me. But otherwise, I'm very clear that this is very correctly solved, and this problem, because I'm saying is so because this problem has been just created by me as it is. So I have validated it. It's still possible that you may find a different way to solve it, but you'll get almost the answer will be very much same. So that was the example 1 which I want to take, and if I take example 2, so this is very not clear, but this is again another system which you can solve. So if you are having your RS here, and this is your B1, this is your B2, and this is your C1, so I will, and this is your C2 here, and this is CS. and both of these are plus and plus signals, and this is a plus and this is a minus signal. Now some things are very clear here. So now I will not go into detail step by step, but I will just write down what I am doing in the step. So in the step 1, what I will do, these both are in series. So series B1 and B2 I will combine, and I can write that this together will form a transfer function of B1 B2. And now then I am left with a diagram, something. If I drop this, if I am left with something like B1 B2 here. And now one thing which I can do is I can move this summing point on this side. If I am moving this side, I will have to divide this by this. So if I am doing that, again I will have to rub this, and it will become something like here there is B1 B2 as it is, because there is no difference, and then there is moving this side, so B1 B2 or C1 divided by B1 B2. So that's how you are connecting that. So that's very clear, and if you move that to the other side, this will be connected to the signal this way. So you will have to erase it here. So this is how it will look at the end of step 2, that is moving C1 on other side to right of B1 B2. Now you will have to solve both these transfer functions, and very clearly you will get after solving this is something like B1 B2 divided by 1 plus B1 B2 into C2, and what you will get by after solving this is 1 upon 1 plus or 1 upon 1 plus C1 divided by B1 B2. Or finally 1 plus C1 this. So you'll have to, if I say finally, what you will get is you will get a transfer function as your signal is RS, and then you will have what is B1 B2 divided by 1 plus B1 B2 into C2 into 1 plus of H1 divided by B1 B2. So this is my answer for my question, and this is the second question which was for block second question answer for block diagram simplification for control systems. The final answer will be, if I say this is my G1 and if this is my G2, then my final answer will be RS is equal to G1 G2 and this is my CS. So my CS upon RS will be equal to G1 G2. If I call that this is my G1 and this is equal to G1, this is equal to, just to simplify, this will be my answer. That's all. I would like to add a few more lectures in this series as I get some time. So I have already prepared 4 lectures, and the full series will have close to 40 lectures, and it will contain the full control system engineering. And to get a quotation for this course, it is very cheap, and if you want to get a quotation for this course, then you can email me at my business email ID, whichever is given. And the meanwhile I will try to upload 5 to 6 or 2 to 3 more videos in this series if possible, mostly 2 more videos. So that's it.